So we're going to give an overview of the Lens Detect software that EA Technology uses to visualize the Visnet Hub monitoring units which are deployed in secondary substations. So once a user's put in their credentials, they'll be taken to this screen. And now Lens Detect is split into three main areas. So on the left-hand side, we've got some basic filters and some overviews that allow customers to look at specific parts of their network, or to look at some of the general statistics of what is actually being measured, and also some filters of any alarms that have come up. So it allows you to drill into specific alarms as they come up in time. In the centre, we've got a map panel. The map allows a user to be able to see where the units are geographically. We use a latitude and longitude information for this. Importantly, we don't take the full network connectivity models to create this, but it does mean that we can visualise where the substations are very quickly just by having the very simple lat and long information. And on the right hand side, we've got any alarms which are up at any given time. So this is the current list of alarms for all of SP Energy Networks' network area as they are visualized today, right now at this instance. If I slide this slider back, I can look at all of the alarms that were in place for the full duration of the last 24 hours, so whether they were up and then cleared. And I can also go back to look at this a week in arrears, so it's looking at the full detail of what's happened over the last week. It does take a little while to process because there's a lot of data that we're pulling up upon at that point. Wait for that information to come up. So there we go. So I'm going to go back to now, and we're going to take a bit of a deeper dive into one part of the network and look at what's actually shown on the individual assets. So let's go back to now. I'm now going to look at the SP ManWeb license area, and you can start to see we've got a very rich picture of Visnet hubs which are live monitoring right this instant and providing details and data back to the network operator. We can split using Lens Detect. We can go into different parts of the network. So you might be interested in looking at the Wirral, for example, or you might be operating in the Mid-Cheshire area. You might be interested or operating in Mersey Valley or in North Wales. The area I'm going to have a bit of a deeper dive is to look at those assets that are in Merseyside. Merseyside is where we start the trial for SP Energy Networks, and we currently have a number of units deployed. What you'll see here is in Merseyside we've got 185 substations which are flagged on the system, of which we are live monitoring 142. You'll see some of these are greyed out at the moment as these are built for the deployment of the Visnet hubs, which are sitting with SP Energy Networks and currently being deployed to substations on a daily basis. So what I should explain is that on the map section I can zoom in or zoom out to look at individual assets, and what we've done with Lens Detect is give an overview about whether there are issues on the network and how they might manifest themselves. Well, let's just dive into one asset and just see what that's telling us. So I'm going to start off with Brodie Avenue South, and what we see here is an overview about the transformer, the bus bar and the feeders. This is a schematic diagram of the network at this point. Each of these is dynamically linked, so we have a red, amber, green status on transformer, the bus bar and the feeder, and then from there we can dive into that in a bit more detail. So this level down now, I start to see the transformer. I can see the three bus bar voltages and the neutral, and I can see that in this instance I am measuring 6 feeders that come off that substation. By clicking in the top half of this window here, I go to the screen that shows me information on the transformer and the voltage. If I click into any of these feeders, it gives me and takes me to the detail of the information that's seen at a feeder level. So I clicked on that transformer, and what I can see now is this is the amount of power that's going through, and where we are right now is here. So just after midday on this day here, and you can see we've got a mimic here which is showing any alarms that might be up. Each of these allows the user to go into a bit more detail around the device and start to see if there's any alarms that are up. Any of these graphics we can filter out. We can look at specific phases if we're interested. We can look at the busbar voltage. We can again look at specific phases if we're interested to see what's going on at any given time. We can also use this slider at the top to say, well, what happened in the last month, or the last week. So I've just selected that to the last week, and what you'll see now is that this profile will change, and you see the daily demand curve with the amount of power that's going through the transformer, and also how the voltages are changing throughout that time, because clearly the network isn't static, so things do change from time to time. Reset that back to 24 hours, and I'm going to take us back now using the back arrow back to this level here where I might want to explore the first feeder. So clicking on the first feeder, that now takes me to a new screen, and the new screen will show again the transformer, again the voltages, so looking at the voltages that are coming into the bus bar, but now we're actually showing what's happening on each of the phases on one feeder. So we've got 3 phases plus the neutral connection. Again, these are all dynamically linked, so if there was a problem, if a fuse had blown, this would now be flagged as red, and this would be shown as open. And we can also start to see more information as being shown down here. So if I click into any of these areas, it starts to filter the information that I see. So if I'm interested in seeing, well, what's the reverse power at any given point, by clicking on this row here, that allows me to look at all 3 phases plus neutral with any reverse power that's going on at that given time. So there we go. We now see the kVA. This unit doesn't see reverse power, and as we're looking at it now, and we also see what the kVA and what the current is. Take that off. This is just a filter. I can also look at phase imbalance, so how much power is going on in the neutral. I can look at any overloads in terms of the short and long-term overloads on the feeders. So that gives some of the basic functionality of the Visnet Hub, just ability to see what's going on the network in real time, and ability to plot that and to see how that might be manifesting itself over a number of weeks and months. So I'm going to go and zoom back up a level, and that's the basic overview about how Lens Detect operates. You can see that there's lots of different substations in here. Just to draw out some of those points we talked about before, if I go back to the license level, these 4 tabs here give me an ability to zoom into specific issues. So which substations right now are exhibiting reverse power? So I can click on that, and it's showing me that I currently have reverse power across these parts of the SP-ManWeb license area that we're monitoring. Some of that might be because the network is remeshed. Some of it might be because we have large amounts of photovoltaics or other forms of generation feeding into the low voltage network. So that's it. If you've got any points, if you've got any observations, if you've got any improvements, please let us know. Thank you.